So we're spending more time working with these trigonometric ratios because trigonometry, it turns out, is really useful. There are right triangles everywhere. Any type of engineering application, anything scientific, architectural, even artistic, you can make right triangles out of anything. And using these trig ratios to find things like missing sides is just an incredibly valuable tool. So if you've got a situation like this, right triangle, I know an angle, I know one of the sides, I'm looking for another side, this is what trig is for. So here are our steps. First, you got to figure out which ratio you should be using. We got 3 of them: sine, cosine, and tangent. In this particular case, the way to determine which one we're dealing with is to label the sides. So we know this angle, hey angle, I have the side across from it. That means this is my opposite side. And I have this side, which touches both the angle and the right angle. That means this is my adjacent side. This is how you make your choice. Think through yours, SOHCAHTOA. I'm going to show you, sometimes folks write it like this. This is a great way to write it. It helps you remember exactly what goes where. SOHCAHTOA. So I've got an opposite and an adjacent. That means this is the one I want. I want my tangent. So the tangent of 67 degrees is the opposite side divided by the adjacent side. So we determine a ratio and we set up an equation. At this point, what's important to know is that tangent of 67 degrees is just a number. It's a big old long decimal number, but it's just a number. And so we can now solve for this unknown. And typically the way you're going to do that is with cross multiplication. So let's treat it like tangent over 1. Multiply across. So 18 times 1 equals x times the tangent of 67 degrees. And remember, tangent of 67 degrees is just a number. So we're going to divide that number now. Over to the other side. Those reduce. I've got the x by itself. So the number I'm looking for is 18 divided by the tangent of 67 degrees. We're now going to go to a calculator and get a decimal approximation. Now this is incredibly important. Super important. If you're using the Desmos or the handheld calculator, you've got to make sure your setting is in degrees. So do this if you have a TI calculator right now. Go into your mode, and on this third line, there's more than one way to measure angles. We want to be in degrees. If you set it once, you don't have to set it again, but check it. Make sure you are in degree measure. That means then I can now just type in, all right, what is 18 divided by the tangent of 67 degrees? That's about 7.6. There you go. Now do check and make sure that that looks reasonable. These pictures aren't perfectly to scale, but they're roughly right. So this side is significantly shorter than 18. Well, 7.6 is significantly shorter than 18. That's a good indication. Now on Desmos, you've got to do the same thing. It's in your little wrench over here. You click it, and if you look at your settings, as I move this out of the way for a moment, you need to click it over to degrees. Once you do it once, you don't need to do it again until you reload a brand new Desmos. So that means you're probably going to have to do it every day. So click it, little wrench, change it to degrees, and then you can do the same thing. 18 divided by tangent of 67 degrees. Look at that, 7.6. If you don't change that setting, it's going to give you the wrong answers every time. And unfortunately, I'm going to have to count those incorrect, which is going to make all of us sad. Make sure you are in degrees. Degrees. Okay, let's do a quick review and then try a couple more. So our missing side in this case has a length of about 7.6. So given our triangle, you have to look at what information you have, label your sides, and choose your ratio. That helps you set up an equation, which you can then cross multiply to solve. Okay, let's do this one. Do a pause, unpause when you're ready to check things. So from the point of view of this 50, the 19 is the hypotenuse because it's across from the right angle. The x touches the 50 and the right angle. That means that's my adjacent side. So thinking through my SOHCAHTOA, A and H is cosine. So the cosine of 50 degrees is the adjacent side divided by the hypotenuse. Cross multiply, so x times 1, that's just x. 19 times cosine 50 degrees. And as I turn the lights back on, sweet heaven, back to the calculator. So 19 times the cosine of 50 degrees is about 12.2. And again, check for reasonableness. As I'm looking at my picture, the 19, that's the long side. So yeah, this should be a little bit shorter, but maybe not tons and tons shorter. It seems reasonable. Now, when I talk about reasonable, I mean, if I would have gotten, say, a 30, or if I would have gotten a 0.5, we should know right away that something's probably not right there. 12.2 seems like something that could be working there. Okay, let's go again with this next one. Quick pause, unpause when you are ready to check things. So as I'm looking at this 40-degree angle, I see that I have this side across. That means this is my opposite side. And I've got across from the right angle. That's always going to be the hypotenuse. So opposite and hypotenuse, that's OH, so my sine of 40 degrees is the opposite over the hypotenuse. Treat this like a fraction over 1, cross multiply. So x sine 40 degrees is 18. Sine 40 degrees is just a number. It's a big decimal number, but it's just a number. So 18 divided by sine 40 degrees. And then calculator it up. 18 divided by sine 40 degrees. I'm going to call that 28.0. Quick check for reasonableness. The hypotenuse should be the longest side every time, so it should be more than the 18. I think we can trust ourselves there. So about 28. Okay, last one here. Once again, quick pause, unpause when you are ready to check things. Okay, so I got this 51. I have the side across from it, so this is the opposite. The 14 touches the 51 in the right angle. That's the adjacent. Opposite adjacent, OA, TOA, so tangent of 51 degrees is the opposite over the adjacent. Let's multiply, x times 1, 14 times the tangent of 51 degrees. Decimal approximation. That was 51, right? So 17.3. Check for reasonableness. Again, it's not perfectly to scale, but it's pretty good. This side looks a little bit longer than that. 17.3 is a little bit longer than that. I think we are in good shape. So determine your sides, set up your ratio, cross multiply, and solve.